morning. Today I'm going to show another hydraulic exercise here in Megatronics laboratory. I'm going to show through this exercise the relationship between the force applied to the actuator and its speed. And I will prove, and I am going to prove that the speed of the actuator is governed by the flow rate, and the force applied to the actuator is governed by the pressure of the fluid. So, here is the power unit. This is the main pressure line, and this is the tank line. Here I put a pressure control valve. We see the sketch on it here. This sample refers to the pressure relief valve. This square, and this arrow for the plunger. This is the input line, and this is the output, and this is the spring, refers to the adjustment by this knob. The output line is going to the directional valve here. It contains 3 connecting positions, 1, 2, 3, and 4 ports, 1, 2, 3, 4. The output ports I have connected with this flow control valve, and in parallel with it a one-way non-retain valve. This is the sample for it. Contains a ball and a rectangular or triangle seat. And this is another flow control valve that controls the speed of the actuator by controlling the flow rate of the fluid. The force applied to the actuator, this is the double acting cylinder. The force applied to it is controlled by the pressure through this valve. I've connected this diagram. This is the power unit. Countered by this line. This is the pump sample. This is the filter. This is the tank. This is the coupling between the pump and the electrical motor. This is the sample of the check valve, and this is the sample of the relief valve. This is another relief valve that controls the pressure applied to the circuit. This is the sample of the directional valve, and this is the handle level for it. It has 4 ports, P, T, and A and B, and 3 connecting positions. The middle one is neutral. The second one is connecting P with A and T with B. The third one connecting P with B and T with A. Then I connect a flow control valve, and in parallel with it is check valve or non-retain valve, and this is another one of flow control valve. Through this set I control the speed of the flow, then I will control the speed of the actuator than the speed of the load. Here, this is the mass sample, and the force applied to this mass controlled by the pressure rate through the relief valve. Let's turn on the pump and see the result. Here is the gauge. Reads that the pressure is zero because there isn't any movement in the actuator. If we make the rising stroke, there is no speed. So the pressure would be increased to the main relief valve to about 20. Then we will operate the experiment. Here we see that the rising stroke is very slow. If I increase the speed of the flow through this valve, I haven't any increase in the speed of the actuator. Why? Because the force applied is very low. Here we see the rising stroke moves with very slow because the force is low due to the pressure delivered. However, I increase the flow rate through this valve. This is the throttle valve. I don't have any increase with the rising stroke as I show here. It's very slowly. But if I increased the pressure through this valve to about 18 bar, we see that it moves faster. Here we will see again the rising stroke moves fast, descending, rising, descending. Now I will make the pressure zero and turn on the pump. Here I proved that the speed of the actuator is governed by the flow rate through the throttle valve in hydraulics, and the force applied to the actuator is governed by the pressure that controlled by pressure regulating valves. Thank you very much.